All right, hi grade 8s. So this time I'm gonna do the screencast lesson video with you. Okay, so we're diving into pulleys and gears. So for pulley, it's really hard for you to imagine this without me showing you a pulley in the classroom. So let's start with a video. Okay, so let's start with this one here, and I'm going to explain it during the video too. So, but the video did a really good job explaining what a pulley is and how to calculate mechanical advantage of it. Okay, so we're just gonna watch along, and then we're gonna jump back to the notes after the video. Okay.
You might think of using a wheel, one with a groove in it, mounted so it can turn, and so you can hang it from something. When a rope is passed over this, it can move with much less friction than it can scraping over a branch.
So that's one pulley, and in the end, I want you to know 3 types of pulleys. One is a fixed pulley, which is this one on the screen, that you can see that you cannot really move it. You just is fixed on the tree or on the ceiling, whatever. Okay, so that's this thing here you see here is a fixed pulley.
The groove in the wheel keeps the rope from slipping off. The whole arrangement, the wheel and the rope that goes over it, is called a pulley. Pulleys are simple machines that help people do work. This one is a fixed pulley because it stays in one place as you use it. How does a fixed pulley make lifting things easier? Suppose you attach a weight or a...
Okay, before he actually tells you, I want to ask you, how do you think if you have a load at the end and you're pulling the load up, how is it easier that you are pulling it down? What's so good about pulling it down instead of lifting it up? If you can actually think about it, it's actually because you can use your body weight, because gravity will do the job for you. You can use your body weight to actually pull it down. It's easier for you, okay? He will explain the video too.
Load here. A pull down on your end of the rope causes a pull up on the other end. You apply a force in one place, and that produces a force in another place to lift a load. The amount of force you apply is the same as the force that acts on the load. If the load...
Okay, he said that the force you apply is the same as the force of the load. So what is the mechanical advantage of this machine right in front of you? If the effort force and the load force are the same. Okay, if the smarter guys, you know that the pulley is actually having a mechanical advantage of 1, okay? I think that the entire class can actually think about that. So when effort force and load force are the same, mechanical advantage is equals to 1. So in this case, it's 1.
Weighs 25 pounds, then you have to pull down with a force of 25 pounds in order to lift it. And if it weighs 50 pounds, you have to pull down with 50 pounds of force, the same amount of force you'd need to lift the load without the pulley. So a fixed pulley does not increase your force. It helps you lift things by changing the direction of force. It allows you to pull down in order to lift something up. For instance, if you want to raise a flag up a pole, you don't have to climb the pole and pull it up. You can put a fixed pulley at the top and raise the flag without leaving the ground.
So direction here, the downward pulling direction here is actually an advantage for us, all right?
And if you loop the rope around a second fixed pulley at the bottom, you can also pull the flag down. If you lift something by pulling it up, only your muscles do the work. But when you pull down, your own weight can help you. Using your own weight as a force, you can raise something that weighs less than you do, but not something that weighs more. But with a pulley, you don't have to use only your own weight. Suppose you want to lift something that weighs 100 pounds. You could hang another weight, a counterweight, on your end of the rope. If the counterweight weighs 90 pounds, that wouldn't lift the load. But all you'd have to supply is the difference, 10 pounds of force, and you could lift it.
So basically then 10 plus 90 would be your effort force, okay, because you're adding a blue block, 90 kilogram, for example, a block here to help you and to lift up the load force of 100, okay?
Fixed pulleys and counterweights are often used in lifting machines, like elevators. Counterweights sometimes make lifting easier, but there can be a big problem with them, especially if they're heavy. In order to use them, you first have to lift them to hang them in place. If you're not strong enough to do that, you still have the same problem as before, how to lift heavy things. To make that really easy, fixed pulleys aren't enough. You also need a different kind of pulley, a movable pulley.
Okay, that's the second type of pulley you need to understand. That's a movable pulley. And how is that movable? Do you see that this pulley here is not attached to anything? If you actually pull the rope, the pulley will actually move with you. So let's see here.
It's called that because it moves with the load. The pulley is suspended by this rope, with one portion of the rope, or rope segment, on each side. Each rope segment supports half the load. If one person supports the whole load, he supplies all the lifting force himself. But suppose two people each hold one of the rope segments. Then they share the lifting equally. They each need to lift with only half as much force. Exactly the same thing happens if one end of the rope is attached to something that doesn't move. If you're lifting the other end, you still need to lift with a force equal to only half the weight of the load.
Okay, so your effort force is only half of the load force. So can you think of what's the mechanical advantage of this machine in front of you? If you think about it, mechanical advantage equals to load force divided by effort force, okay? So if load force is 2 times then the effort force, or let's say effort force is half of the load force, we can say mechanical advantage. It's actually saving us effort. So it's mechanical advantage bigger than 1. In this case, is 2, okay?
This end still supports the other half. And because the rope can roll through the pulley, when you pull up with your half, you raise the whole load. So when you apply a force here, the pulley lifts with twice as much force here. With 10 pounds of force, you can lift a load that weighs 20 pounds.
So that's what I meant by mechanical advantage equals to 2, because 20 divided by 10 is 2. When mechanical advantage is bigger than 1, it's saving you effort. Right now, it's saving you half of the effort, okay? So that means mechanical advantage equals to 2 means you can lift double the amount of weight of your effort force.
Of course, now the load includes the weight of the movable pulley. With 25 pounds of force, you can lift a load that weighs 50 pounds. And with 50 pounds, you can lift a 100-pound load. But with machines, you never get something for nothing. To get this increased force, you have to move your force an increased distance.
Okay, when your effort force is really small, the distance you have to pull, or the distance your hand moves, should be really, really big. Okay, so it's actually proportional. If force is halved, the distance is doubled, right? So let's see here.
If you want to lift the load a distance of 1 foot, you have to move your force 2 feet.
And that's when mechanical advantage is equal to 2, okay? So it's actually effort distance divided by load distance. So 2 over 1 in this case.
To move the load 2 feet, you move 4 feet. Always twice as far. So when the movable pulley is suspended by 2 rope segments, you have to exert your force over twice the distance the load moves, and in exchange the pulley lifts with twice as much force as you do. But one big problem with movable pulleys is that you have to pull up, and for heavy loads that's not always easy. You need something that will allow you to lift by pulling down instead. But that's what a fixed pulley does. Suppose you combine the fixed pulley with the movable pulley to get the advantages of both. The movable pulley still doubles your force, and at the same time, the fixed pulley lets you pull down.
Okay, so that's when you combine movable pulleys. So one movable pulley on the left and one fixed pulley on the top. So when you combine the pulley, it's a pulley system now. Okay, so when it's a pulley system, you can actually pull down and also saving effort. If you add more pulleys, if you add more movable pulleys, you're getting more mechanical advantage. But in this case, okay, because there are two strings suspended to actually support the movable pulley, your mechanical advantage for this whole pulley system here is actually 2. And why is that? He will explain it in this with the image.
So here, finally, is a simple machine that really does make lifting easier. With this arrangement of pulleys, you can lift twice your own weight. One way to compare different pulley arrangements is to use the idea of mechanical advantage.
Okay, this is a really important concept in pulleys, okay? You have to know how to calculate mechanical advantage for pulleys. Or in this case, not calculate, it's just counting, okay? You have to know what to count.
Since this pulley arrangement doubles your force, it has a mechanical advantage of 2. You can find the mechanical advantage of any pulley arrangement by simply counting the rope segments that support the movable pulley.
Okay, I'm going to repeat that. By counting the string segment that actually supports your movable pulley. So basically you see where your movable pulley is and you see the 2 strings are attached to it. So basically that system has a mechanical advantage of 2. Okay, so if you have 2 movable pulleys, most likely you will have a mechanical advantage of 4 because there are 2 strings that support each movable pulley.
In this case, 2. It doesn't matter where this end is attached, so for convenience you could attach it here, like this. The mechanical advantage is still the same because the number of rope segments that support the movable pulley is the same, 2. Why isn't the mechanical advantage 3? Aren't there 3 rope segments? You don't count this one. You only count the rope segments that directly support the movable pulley. A mechanical advantage of 2 is some help. But if you need to raise very heavy loads, you need more lifting force. You get it not by adding more muscles, but by using combinations of pulleys that give you more rope segments. Suppose you add another fixed pulley, for instance, and run the rope this way. Now 3 rope segments support the movable pulley, so the mechanical advantage is 3. Or suppose you start again with this combination, and then add another combination just like it. So you have 2 movable pulleys and 2 fixed pulleys. And then hang the load from both movable pulleys. Now, how many rope segments support the movable pulleys? 4. So that's the mechanical advantage. But what?
So you basically count the string segment that actually directly connected to the movable pulley, okay? It's supposed to be really easy to calculate mechanical advantage in pulley systems.
Why does this combination make a mechanical advantage of 4? How does this work? Let's imagine that you and 3 other people were each holding a segment of the rope. It would be clear that each person would support 1/4 of the load. If the load weighs 80 pounds, each person supports 20 pounds. But it doesn't matter what holds up the segments. So if you attach this segment here and join these 2 segments over a fixed pulley, each segment still supports 20 pounds, and you still pull with 20 pounds.
Okay, so what's the mechanical advantage in this case? Should be your load force over your effort force, which is 80 over 20, which is 4. Okay, so basically you just use 1/4 of the force that you should apply.
But because the rope can roll through these pulleys, when you pull up with 20 pounds, that raises the whole 80-pound load. The pulley system multiplies your force by 4, so 4 is the mechanical advantage. To make things even easier, you can add another fixed pulley, so you can still apply your force to this rope, But now you can do it by pulling down with 20 pounds. The movable pulleys are still supported by the same number of rope segments. So the mechanical advantage is still the same. The pulley system still multiplies your force by 4. And in exchange, you have to exert your force 4 times the distance that the load moves. You trade distance to get force. Now, suppose you arrange these pulleys in a much more compact way. You can put these two pulleys next to each other on the same axle. The same with these two. The pulleys still work the same way, and the mechanical advantage is still 4. This device is called a block. This is another block. The whole system, pulleys, blocks, and ropes, is called a block and tackle.
Okay, you don't have to actually know how to set this up and something like that. You just have to know when you see this several pulleys stacking up, that's called a block and tackle. Okay?
The more pulleys and rope segments in a block and tackle, the greater the mechanical advantage, and the heavier the loads you can lift.
Okay, so I'll just pause the video here because you got most of the stuff down. Okay, so let's finish the notes here. It should be easy for you now since you watched the video. Let's just fill it up. Okay, so pulley. So yeah, basically a pulley. Oh, it's too thick. Okay, basically a pulley. It's a wheel with a grooved rim to guide a rope or chain that runs along the groove. It'll used to change the direction of force because you're instead of lifting up, you're actually pulling down. In this case, pulling down. Okay, you're using your gravity and your body weight to actually do the work for you, which is easier. All right, so when you only have you have a ceiling, you have a fixed pulley there to actually have the rope there. That's a load, and that's you're pulling it down here. So this pulley here, that's called a fixed pulley, and has only mechanical advantage of 1 because you're only changing the direction without changing the effort force. Okay, so a fixed pulley, that's what it's called. Okay, so and also beside the fixed pulley, there's another kind of pulley, which is actually this pulley here. This, and this. If you watch the video carefully, it's actually called a movable pulley. All right. Okay, so you have, and then you have pulley systems, right? Fixed pulley, movable pulley. When you attach a lot of them, that's called block and tackle in this case. Okay. All right. And a combination of several pulleys working together, that's called a pulley system. In your grade science 8, these two terms, it's basically, it can mean the same thing sometimes. Okay. In this case, mechanical advantage of pulleys. You know this already when you actually watch the video. I really love the video. Hopefully, like if you don't understand it, you can just always go back and watch it again. Okay. So when you have only one fixed pulley, you're only changing the direction of force. So mechanical advantage equals to 1. Because you're not actually saving effort, you're just changing direction, so it's easier for you to pull down. Okay, because you you can rely on your body weight, and gravity will do the job for you. So split the weight has to lift. So when you have a one movable pulley, like we said in the video, when there's one movable pulley, you count the string segments that actually attached to it. So there's one string to it, another string to it, so it's 2. Sometimes we say that is the amount of movable pulley times 2, but you don't count that now because sometimes the system arrangement or the pulley arrangement is a little bit off. So you just count I'll just take a note here. Count string segments attached to the movable pulleys. Okay, so this case is 2. So that means if the object is 40 Newton, your hand needs to apply 20 Newtons of force, like that. Okay, pulley system in this case, same idea. You just count the string segment that actually attached to a movable pulley. So here's my movable pulley. Strings attached to it is 1, 2. So mechanical advantage is 2. This should be one fixed and one movable in the picture. Okay, and what's the point of this fixed pulley being there? It's actually just to change direction. Okay, to make your pulley easier. Okay, let's think about this question here. What's the mechanical advantage of this pulley here? So let's count the string that's actually attached to the movable pulley. So it's 1, 2. Oh, by the way, let's figure out what's the movable pulley first. This is movable. So string attached to it, 1, 2, 3, 4, 5, 6, 7, 8. So mechanical advantage should equal to 8. Okay, in this case. So my next question is, if the wood block or the load is actually, let's say, 1,000 Newton. Okay, it's actually 1,000 newtons. So, or let's say not 1,000. Let's just I'll give you a good number here, 800 newtons here. So we say that when mechanical advantage is equal to 8, it's actually half 8 times of the force for you, or reduce half 8 times the force for you. So what's the formula for mechanical advantage again? So is a load force over effort force equals to 8 in this case, basically. So mechanical advantage equals to. So load force is 800 Newton, question mark. And question mark therefore equals to 800 over 8. So because if you put into a triangle, it's 800 on top because it's on top of the fraction here, and 8 and what's on here. So you divide them to get 100 Newton. So to lift up with 800 Newton of load, you only need 100 Newton of force. That's why mechanical advantage equals to 8 in this case. Okay, so all your practice problems will be like this, and I will, it's already on Dropbox actually. I'll just show you where on Dropbox do we have this. So the next one is gear. Gear will be in your next lesson, okay? So Dropbox, once you get into my Dropbox, click in the enter Unity folder first, and then lesson pulleys and gears. So I didn't really have a field notes here. I can upload the field notes I just did with you guys, but I want you to actually do. This is a pulley lab we just did. Oh, by the way, I kind of want to talk about this one with you, but it's okay. Let's talk about that later. But your homework is the pulley worksheet. Okay, please finish it. The first page, let's see what else. Okay, so this is actually good. So the practice problem, please do it. Print out this page, and then the answer key, I will upload it tomorrow. Okay, and then please do it, and review about pulleys. To help you with this worksheet, I'm going to show you something that I want to emphasize here. So I want to see this. I want to talk about this one here. Okay, this is a bunch of examples, and I want you to tell me what's the mechanical advantage of each. So in this one here, remember how do we count mechanical advantage for pulley systems is when we count the movable pulley amount and then count how many strings are attached to it. Okay, so in this case there's no movable pulley, it's only one fixed one here. Hopefully you realize, let's say this is all ceilings. Okay, so there's only one fixed pulley, so mechanical advantage in this pulley system here, or the pulley setup here, is 1. So the effort force you need to apply to lift up 100 Newton is still 100 Newton. Okay, so in the second one here, let's count movable pulleys 1. So the string attached to it, 1, 2. So we can say mechanical advantage equal to 2. And so originally it's 100 Newton, now you only need 50 Newton. Okay, because basically you are asking yourself what is load force over effort force equals to 2. So in this third one here, mechanical advantage equals 2. Let's say this is the movable pulley. How many strings are attached to it? 1, 2, 3. So mechanical advantage equal to 3. So 100 over 3 is actually not cannot be divided to whole number. So I'm just going to give 33.333 ongoing newtons effort force. So in this case, 1, 2, 2 movable pulleys, 1, 2, 3, 4 strings are attached to it. So mechanical advantage equals to 4. 100 Newton over 4. You need about a quarter of the effort force to lift up the 100 Newton. Okay, and the last one I want you to think about yourself. You can pause here and do it yourself. Yeah. Okay, so movable pulley, 1, 2, 3, string attached to it, let's count here, 1, 2, 3, 4, 5, 6. So mechanical advantage equals to 6, and the effort force therefore should be 100 over 6. I guessing it should be 1 and then 16, something like that. So it's going to be a decimal. Okay, I don't have a calculator right now, so I don't count it, but this is how you calculate it. So you need that much of a Newton to actually lift up 100 Newton of weight. Okay, so yeah, please do the homework on the Dropbox. Okay, I'll see you in the next lesson.